In this video, we're going to learn about synthetic division. It's basically a shortcut of long division. Why do we have to learn long division then? Because synthetic division only works with divisors that are in the form of x plus some number or x minus some number. But before we get to synthetic division, let's just review that long division process. So we have a divisor of x minus 1. And then we have a dividend of 9x squared minus 5x plus 1. First of all, notice everything is in descending order. Your polynomials, 9x squared, then x, and then your constant. We don't have any missing terms. So that division process goes something like this. We look at those first terms and we're dividing those. And we're saying if I divide that, I would get 9x. So we put that on top. And then we multiply that. We get 9x squared minus 9x. And then we need to subtract. So subtracting is just adding the opposite. And the idea is for that to always cancel out. And then we have a positive 4x. Then we bring down the next term and repeat that process. So again, we divide those front two. And we say 4x divided by x is positive 4. So I put that positive 4 up there, and again I multiply that 4 times the divisor, which is 4x minus 4. Then I subtract, which changes the signs, and I get 5, and that is your remainder. And you would put your remainder over your divisor, and that's your answer. So it's not hard, but it is long, and if you have higher degree polynomials, it's a longer process. What would that look like if it didn't have any variables? So I've removed all the variables. It looks kind of funny, but I wanted to kind of look at that as we learn about the synthetic division. We're going to use the same problem. We still need to have everything in descending order. If we're missing any terms, we need to fill in placeholders. But let's look at this. Right? So that's going to take the place of this top line. So I'm going to write 9, negative 5, positive 1. Then I need to take care of how am I dividing. So instead of a long division symbol like this, I'm going to turn it upside down and make it shorter. What number am I going to put there? Well, you're going to put the opposite of what's in here, or in other words, set that equal to 0 and solve for x, and that's the number in there. But I still like to think about it as the opposite sign of that number. So now we have our setup. I'm going to draw a line. Notice I've used notebook paper. So those notebook paper lines really help you in long division and synthetic division. We're going to first bring down this number just as it is. Then just like up here when we multiplied 9 times out there, we're going to multiply by what I call, this is the box. I'm going to multiply that and I'm going to put it in the next column. Kind of matches that column, and I'm going to add those numbers and I get a positive 4. Then I'm going to repeat the process just like I did up here. I had this 4 and I multiplied out there. I'm going to multiply this 1 times that 4. I'm going to put the answer here and I'm going to add those numbers just like that. And believe it or not, you've done synthetic division. The last step is to write your answer. Notice your answer was 9x plus 4. That's 1 degree less than what you started out with. So if this is 9x squared and you're dividing by an x, that's going to go down 1 degree less. So I have 9x plus 4. This is always your remainder, and you put your remainder over your divisor. So instead of taking 1, 2, 3, 4, 5, 6 lines of notebook paper to work the problem, we have 1, 2, 3, and we're done. As long as you can add and multiply, this is a very easy process. Let's look at these next examples. Here we have a plus 1. So in my little division, I need to take a negative 1. You can either think about that setting it equal to 0 and solving for x, or just know that you need the opposite. Then let's look at those numbers. The x's are in descending order, but are we missing a term? Yes, we are. We need what's called a placeholder here. What's missing? I have x cubed, x squared. What's missing are the x's, and I need a placeholder for that. So let's put the 2, skip a little space, -5. All right, so this is x cubed, x squared. I have 0 x's. That's your placeholder, is a 0 and a -3. Then we're going to draw the line. We're going to drop this number right down here. Okay, you don't have to draw those arrows. I'm just kind of showing you. Drop it straight down. Don't do anything with it. Then you multiply those. Put the answer right here. Add. Multiply. Add. Multiply. Add. Now you're done. Write your answer. This started out with x cubed, so your answer is 1 degree less. So 2x squared minus 7x plus 7. That's always your remainder. So you could say plus a negative, but I'm just going to say minus 10 over your divisor of x plus 1, what we started out with. Isn't that easy? Don't you wish it could always be that easy? Let's do another easy one. Can you spot the placeholders? Well, it starts out with x to the 4th. Now there's a 1 in there, so I have a 1x to the 4th. What's missing? X cubed. Then we have x squared. Then I have x. What comes after that, believe it or not, should be what's called a constant. You always need that constant term, the one without the x, so I need to put a 0 there as well. So I have 1x to the 4th, 0x cubed, -5x squared, 10x, and 0 for my constant. Okay. What goes in my box? I'm going to take the opposite of that number, which is -3. So drop that first number down, multiply, add, multiply, add, multiply, add, multiply, add. Then write your answer. So again, we started out with x to the 4th, so we want 1 less than that, so we have 1x cubed, and then just descend. We have x squared, then x, then constant, and then that's your remainder. Since it's positive, I'm going to put plus over that divisor. Now, what can synthetic division be used for? Well, that kind of comes in college algebra. It is actually a different way to factor. Let's look at problem number 4. Instead of using long division or synthetic division, let's just see if we could reduce that by factoring. So it's a good chance to review the cubes. Remember, we have x plus 5, and we're going to square that, multiply those together, take the opposite sign, square the last one, and then divide by x plus 5. So we could reduce that out and have that as our answer. Now that's division. That's just dividing by factoring. Could we work that problem the same way if we use synthetic division? And let's see if we get the same answer. Right. So as I look up here, I have 1x cubed, but then I have 0x squares, 0 x's in my constant. So I've got lots of placeholders. I want to take the opposite. So -5 is my opposite. 1x cubed, 0x squared, 0x, and then 125. Bring down that 1. Multiply. Multiply. Write your answer. Started out with x cubed, so that's 1x squared minus 5x plus 25 with no remainder. Notice, same answer, 2 different techniques. So just some reminders. Make sure everything's in standard form in descending order from x cubed, x squared, x, and then your constant. Make sure you fill in all missing terms with your placeholder of 0. And then the last step is, don't forget to write that answer. And that answer is always 1 degree less than what the numerator was, which was your dividend.